Here we go again. Okay. This was the brute force way. I didn't put the visited set here. I don't really need a grid score anymore with the way I'm gonna do it. Okay, so what I want to do is keep track of all the previous nodes at every node. So before exploring this node, yeah, so it's when we explore it that we want to know the previous one. So here it's the next one. MDR, MDC. Oh, but that kind of clues me in to where it came from. So yes, I want a grid with the previous ones. No, I can store them as a map of coordinates with previous ones. Okay. So then whenever you visit, oh, but the start is the only exception, which is kind of annoying. Oh, but it's the only place where the score is 0. So that's fine. So then if score is not equal to 0, you kind of want to add them in any case. So if score is not equal to 0, then paths at, so previous one is yeah, so the current one is row and column, and stored as a tuple. And then you'd add to it the previous one, which was row minus dr, column minus dc. And then if row and column isn't visited, then you skip this one. And then this should still give me my answer here, seats. Okay, so in that case I don't really need the paths here anymore in the heap. So this should still give me the answer. So 36. That's the answer. That's right. seats. So when I reach the end, I want to run a reverse DFS. At the same time, I can do it with the coordinates. I'll do it like this. So I kind of have like some separation in my logic. So that's after I run the Dijkstra. I also want the paths. As a list, yeah. I mean, this seat can be outside, I don't care. So then if the grid columns equals to start, then seats dot update path, and then return. And the path is gonna get extended, and then we shrink it. So I guess path dot append, and here path dot pop, and here the one that we append is this one, the row and column. And then with DFS to it. Wait. That makes sense. But I wouldn't want to append pop for every iteration because it's exactly the same one. So append before and after. Okay. Oh man, maximum recursion depth. How's the maximum recursion depth? Oh, could there be a cycle in there? So I guess I kind of need cycle detection. But when I back out, I kind of I guess I can do a linear check, I don't care. Do it like this for now, see if it works. Okay, 45, that works. Second example, 64 is expected. 64. And then for the test the puzzle input. $5.96. Ah. Fuck. Why did it work? but not for this one. Fuck. How do I output to a file? Forgot. Turn, 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 turn. Does that include paths that are not optimal? So it was too high. I guess I could also keep track of the score and ensure that it's minimal. So how do I keep track of the score while doing the DFS? So I know the previous one is where? But going into it, I don't know if it turned or not. So I guess I could keep track of the cost of that move. I mean, the easiest way would just be sending the cost through the heap. So it'll be the value here. So now we know the previous one and the cost it took to move. So we'll just add the cost here. So now that we know the cost to make that move, in the DFS we can add up the cost. So at the beginning the cost is 0. And when you DFS, you get previous row, previous column, and wait, I'll call it total cost, I guess. So then here will be total cost plus cost. And then once we reach here, if the total cost is equal to the answer, then we'll add it. And I mean, might as well run it. Fuck. Not enough value to, okay. It's because of the initial setup. I mean, the cost here is 0 for this first one. Okay, 517. I think that might be the answer. Fuck, too low. Wait, 49? And 37. Oh wait, that's bad. I know the cost to reverse it. Oh, because it doesn't take into account the rotation there. So this way doesn't work actually. So at least I know the answers between 517 and 596. One, two, three, four. This is 1001. Wait, so if we know the cost to get there, and while we're here, to undo that move depends on how it's oriented. Okay. We're doing reverse traversal. When we reach it, there's only one direction from which we could have reached it, right? Was there another way to reach it from another angle? No, I don't think so. Because I'm overcounting. So there's only one angle to get to the last node. So I kind of want to keep track of score while doing the reverse traversal. Right now in the reverse traversal, previous nodes, I only know the row and the column of the previous one. How do I know if I'm doing a rotation? Okay, so I know the previous node, and I want to know the angle at which it's coming. I'm doing Advent of Code Day 16. The way I'm trying to do it is I did Dijkstra to find the shortest path, and then now I'm trying to find all possible paths. And to do that, what I decided to do was keep track of all previous nodes at every node, and then run a reverse DFS. I tried to do brute force it with just Dijkstra, but the algorithm takes too much time if I don't keep track of the visited nodes. Right now this is like my current solution. It gives me an answer that's too big. And also I found an answer that's too small. So I know the answer is between 517 and 596. It just means that I'm overcounting right now. I thought by doing a DFS reversal of my Dijkstra, it would give me all shortest paths, but I think it's also giving me paths that are too long. I'm not sure why. Because in theory, Dijkstra should be given at every node. Wait, if a node gets visited, is it necessarily because... Yeah, if a node gets visited first, or wait, no, it's the last visit that's necessarily the shortest one, right? I might get visited again, but it's a longer path. Fuck. Oh. Oh, why doesn't it work? I'm keeping track of all previous nodes. I do the reverse traversal. I'm on day 16, part 2. I'm overcounting the answer for part 2. I know the lower bound is 517, upper bound is 596. I don't know why I'm overcounting. I ran Dijkstra to find the shortest path, and while running Dijkstra, I stored at every node. Oh, day 12? What's day 12? Oh, this one. It's the geometry problem. On part 1 or part 2 are you stuck on? Part 1? Do you know how to count the area? I DFS'd it. Uh, I just DFS'd it, and at every node I did some counting. I don't know if you want me to give you the like a spoiler or just give you the answer. Oh, you don't know how to DFS? Like the DFS is similar to the Leetcode question, number of islands. I don't know if you've heard of that problem. Oh yeah. So this is a number of islands if you're interested in learning DFS. It's similar type of problem. If you're able to do number of islands, then day 12 you should be able to do it. If you can't do that, then you're just not equipped. I was in software engineering. Right now I decided to be an electrician. I didn't really like the work of software dev. I just like programming as a hobby, honestly. I prefer being hands-on. Thank you, thank you. Yeah, I just started streaming my programming for fun. I've been doing Leetcode dailies every day for started like a month ago maybe. Let me check. Yeah, 43 days ago I've been doing Leetcode dailies. I have about 350. Yeah, 358 Leetcode solves. And I started doing Leetcode competitions. So last week was my first, and 2 days ago was my second Leetcode competition. I am gonna stream them too. Yeah, finally. I mean, if you want programming help, you can message me on Discord or Instagram. I put my how do you call them? My usernames in the description of this video. You have my Discord and my Instagram. Feel free to DM. I can basically just help you through. I can tell you how to do Advent of Code up to day 16, part 1, because I still can't do part 2. So I want to keep track of the score. So if I'm at the end, okay, I can keep the orientation at every point. So when I reach a particular node, I want to know what orientation I was facing when I entered it, and that orientation is DR and DC. So I'd stored the RNDC inside the previous node. Alright, perfect. So, adding me on Discord, right? Are you in computer science or something? Or are you just like programming for fun? I don't know, maybe you're just a young kid deciding to program while he's young. Engineering physics, that's cool. Yeah, programming is just useful in anything, honestly. Just whenever you have like lots of tedious shit to do, you can just program something to do it for you. Especially like when you're in a field that does a lot of math. Even like stuff that can be physical, you can program like a robot to do it, but that's a bit harder, I think. Well, probably not harder, just a different set of knowledge. DRDC. So I'm at this one. I'm at this node and I know the orientation. I'm about to DFS to the next one. If I DFS to the next one, I kind of want to know the orientation. So I know the orientation of the previous node. So when running DFS, DRNDC, wait. So I'm at the end and I want to know the orientation as well. So when I DFS, how do I know what score to add? Okay, so previous node of So I know the previous direction. I want to compare it to the current one, which is the RNDC. So I also want to keep track of score. Value. Okay. So I think this keeps track of it. Also, I want the orientation of the ending. So let's call it end orientation. And it'll be DR and DC. So then this should be end orientation 0 and orientation 1. One, two, three, 4, 5, 6. 3, 4, 5. Pass. Oh, and the score is 0 at the beginning. 568. Okay, let's go. I think that's it. Let's go. Okay.